So our talk is titled, Let a Bot Deal with Your Static Analysis Warnings Backlog. Some of the terms may not be clear, but I promise by the end of the talk you'll understand everything. We'll make it very clear. Um, so, so this is, we have divided our talk into these four subsections. We'll talk about, to keep everyone on the same page, we'll talk about what static analysis warnings actually are, how are they relevant, and then we'll talk about our tool, which is called Sorald, and how it deals with static analysis warnings. The third is it's a real tool. It's a real tool. It works. So we also have a demo for it. And the fourth is we have done some experiments in the research area with it, and we'd also like to show off our results, showcase our results. So before going further, we want to give a brief introduction of ourselves. So my name is Aman Sharma, and I'm from a university. I'm a research engineer at KTH, Royal Institute of Technology, which is a university in Stockholm, Sweden. And my friend and colleague.
I'm Khashayar Etemadi. I'm a fourth-year PhD student at KTH in Sweden.
Okay. So, okay, let's define it in one single sentence, what static analysis warnings actually are. I know it's very basic, but just to keep everyone on the same page. So it's a potential bug in the program found without executing it. So but let's motivate better with an example. So look at this line. Seems pretty harmless. Just a dot equals it seems pretty harmless. But if you attended Stephen's talk yesterday, it's not that. It's very harmful, because what if it was something like this? It was declared some 10, 20 lines above, it was declared like this, and A was never changed. So this could potentially throw a null pointer exception during runtime, could cause denial of service and whatnot. So probably a better way to do this is, not probably, a better way to do this is this, because by definition, string literals are not null in Java. Okay, so those lines, but how do you find them? I mean, you have hundreds and thousands of lines of code. How do you find them? So we have industrial grade. Thankfully, the problem is solved, and we have industrial grade tools for it. So one of them is Codana Static Analyzer, which is by JetBrains. So if you run their tool, this is one of the examples which they give. So you can see it underlines it, and it says, okay, there's some problem with it, and they give a small message what exactly wrong with it. Another tool which we'll be focusing on more is SonarCube, which is by SonarSource, and they also do a similar thing. They have different ways of saying, but they're saying the same thing. But and so they say this message. But one thing to note here, this rule. It has an identifier. It's 1132. It'll be very relevant for the later of the talk. So it basically has to let the machine know that there's some error. It gives this rule key, so that now we can proceed with it. Okay. So so these bugs, they don't actually they're not exactly they're the byproduct of the development process. I mean, you do not intentionally, you do not introduce it, or it's not so, but it's still a bug. You need to care about it. And but unfortunately, not a lot of developers care. I mean, it's not their fault. I mean, they have a lot of things on their plate. They're busy with their development process, some development pipeline. So we want something, more actionable. Something more actionable which is required, which is this, so that they can delegate their work. So maybe a bot would be required, bot which would just do the work for them, fix those warnings for them. Yes, so that's exactly what we came up with. So yes, Spoon Lab, it's under Spoon Labs, it's called Sorald, and it's a real thing. It's hosted on GitHub. It has 60 stars. I mean, yeah, I know it's not much to flaunt in front of you industry folks, but still. So but yeah, we do not have a logo. So it's an open call for graphic designers. Please reach out to us. Yeah, but yeah. it's enough for us. Okay, again, something more basic. I'll not spend much time here, but still. So, so before we dive into the technicalities, let me just have these basic concepts clear. So we'll talk about abstract syntax tree, which is a tree structure to represent the structure of the program. So for example, this snippet could be represented as this, main, int, return. Like this is one plausible tree that you can have multiple ways. This is just one example, just to give you a brief. So, okay, so we talked about abstract syntax tree because we wanted to talk about Spoon. So Spoon is a library which is built on top of Eclipse JDT core, and it's a library which has been maintained for, let's say, 15 years easily, and we use Spoon because it provides us with these two important features. These are very important for us. So first is the AS tree transformation. So if you see this tree and I updated the value from 0 to 1, you can do anything. You can add a subtree, you can delete a subtree. So that's a transformation. And then the other thing which is important for us is the high fidelity pretty printing. So the abstract syntax tree, the word abstract is because it does not store the formatting information, right? So we need to somehow print it into an actual program that the user can read, use, execute. So yes, so these are the two features which we use extensively in Sorald, and that's why we use Spoon. Okay, so let me put it like a 5-year-old, how it works. So as a user, I go to Sorald, hey Sorald, please, take this program, repair this for me. Sorald is like, yeah, sure, I'll do it. Let me call SonarQube. And SonarQube, and it says, okay, SonarQube, find the violations for me. SonarQube says, okay, yes, I find S1132 at line number 3, column number 8. Okay, Sorald says, okay, fine. I'll find the AST, I'll do the transformations. And then say, hey, Spoon, can you please make it pretty for me? Okay, and so Spoon does the high fidelity pretty printing work, and then it gives it back to the user. So this is what is happening. A bit more technical. There's the program. So SonarQube says, okay, there's one instance of S1132, and then the AST is transformed, and then it's pretty printed. And being more technical, don't need to understand this code, but this is how it actually looks. This is the AST transformation which is happening. This is one of our processors, and we have around 29 more of these for each different rules. Yes. Okay, so I've given you a brief, but how do you actually use it? These are just concepts. We need to do something with it. So there are 3 ways. First is the convention way. We have a jar for it, jar file. We have hosted it on release page. It's on Maven Central. Download it from there, pass it to the jar flag, and then invoke repair, and it'll do the job. The second one, personally, I find it slightly more convenient. It's because it's a Maven plugin. You don't need to download anything, just you need to have Maven, of course. But so you have Maven, and then you invoke the repair goal, and it does the job. And the third one is really good, and because it's integrated into the development process. So imagine you're working on the project. You push a commit, okay, and then your CI builds. They find there's something, there's some static analysis warning detected. So and if Sorald can repair it, the CI will submit a PR to so the developer can review it, merge it. So since we have limited resources in the research group, we can't focus on all 3 of them. So we would like your feedback on which one is your favorite. You can choose multiple options, but let's not stop the talk. This QR code will also be available at the end, so you can scan it and then give us the feedback. Okay, so my colleague and friend will give you a brief demo of it.
Yes, just to see how it actually works in practice, we'll have a short demo in our demo. Sorald has two different modes. First, you can use it to mine the violations. It uses SonarCube API to mine the violations. So first we'll mine the violations, then we'll use the second command that Sorald has to fix the violations or repair them. Then we remine the violations to make sure, to see if they are fixed or not. And finally, we will compile the project again to see if after fixing it, we have caused or introduced any compilation error. Yes, and to be more concrete, these are the commands that we will run. First of all, we'll work on this project, Sonar Scanner CLI, that is developed by Sonar Source itself. So we'll get that project. Then we'll use the Maven plugin mode. As Aman said, there are 3 different modes in which you can run Sorald. One of them is using the Maven plugin. And we are going to focus specifically on the rule S1132 from SonarQube, which means that when you are comparing a string variable with a string, literal string, the literal should come before the variable. So if you have a dot equals foo, it should be foo dot equals a. That's the suggestion by SonarQube. And here is the exact definition they have. They say strings literals should be placed on the left side when checking for equality, and you will see how it can be fixed. And at the end, we'll also remind the violations and compile the project, as I said, to see if any failure has been introduced to the program. So let me go to the terminal and have this. Yes.
Yeah, you need to copy the other thing. It's the commit.
Yes. Let's go. Yes, we had downloaded it before. So let's clone the project. Now we can go inside the project. And now we can run the mine command to see if there is any violation or not.
I just clean the screen before you run that command.
Yes, let's clean it. And we pass it this this argument handled rules, which means that we want to mine only the violations that can be handled by Sorald itself. Yes? Can you say it again?
No, it's a typo. So you can, that spelling of handles is wrong.
Handled, yes.
Thank you.
Thank you. Handled rules. Yes. So it's just getting the dependencies required for this check, and then running the mine command to see if there are any violations that we can handle or not. So just wait a little. So here you see it produces a list of rules that are handled here with the number of violations of each of them. So there's also a stats file that is generated. You can generate it by passing another argument that has all the data, not just this list. And here in this list, you can see that there are 3 different rules that have 1 violation at least, and the other rules have 0 violations in this project. And the one that we are going to fix is this 1132. So there's 1 violation of this rule, and now we want to fix it and see if it gets fixed or not. Let's clean this again. And and now we have to pass the rule key. So we say we want to fix violations of rule 1132. And again, it will run Sorald this time with the repair mode to check if it can fix anything or not. As you see, it doesn't take that long. So here it says that one violation has been fixed by this processor, and now we can run the mine command again to see if it's actually fixed or not. So here we had the mine command. Let's run it again to see if rule S1132 violations are fixed or we have something left. So here you see the list. There are only 2 rules with some violations. There were 3 before. And rule 1132 is here, and we have 0 violations left. So it seems to be actually fixed. Now we can also see, let's see what has been changed by Sorald. Yes, this is the change that Sorald has made. So here there was an if condition, and we had this expression which had this string variable, compared it to this literal, and now these two are swapped, and you see that it's how it's actually fixed. Now we can also run the compile command to see if we have introduced anything that is failing the compilation or not. And you see it's being built successfully, so there is no problem here either. So that's how it works overall. There are many arguments you can add to do other things. You can check them out in the README file. Yes?
Go to view and then to slideshow.
Yes. So now, experimenting in the wild. So we have the tool. We also conducted some experiments to see how the tool works in the wild. For our experiments, as we wanted to work with real projects, we collected 161 projects from GitHub. So these are the criteria we had for the projects that we collected. All the projects had more than 50 stars to make sure they are at least somewhat popular and people actually use them. And they were PR and CI friendly. They had some PRs merged, and they had a Travis CI configuration file. They were active, meaning that they had some commits recently, and they were Maven projects, and they were healthy, meaning that you could successfully run Maven compile on them. And as I said, we fixed different rules from SonarQube, violations for different rules. Actually, 30 rules have been implemented in Sorald right now. Violations of 30 different rules can be fixed. Here we focus on 10 rules. The rules that are of bug type, there are different types of rules in SonarQube. The bugs, the vulnerabilities, and code smells are 3 of them, for example. And we focus on bug type, and we also focus on the rules that have some instances in previous studies to make sure these are rules that actually matter. And here is a list of rules that we worked with in these experiments. And you see, for example, number 1 says thread.run should not be called directly. Number 8 says toString and clone methods should not return null. And here is the full list of rules that we considered. So in the first experiment that we conducted, we ran the Sorald tool on the latest version of each project to see how many violations there are and how many of them get fixed. We had 1,300 violations overall of these 10 considered rules. And Sorald fixes 65% of them, something around 850 violations successfully, and it doesn't introduce any failure, test failure, compilation failure for these fixed violations. In the second experiment, we considered commits in the last year in 350 days in these projects, 161 projects, and checked if any of these any of these commits were introducing new violations of the considered rules, that those violations could be fixed by Sorald. So overall, we checked that 80 newly introduced violations would be fixed by Sorald, and these fixes would be done with 54 patches that Sorald generated, because some patches fixed more than one violations. And finally, as Aman said, we have one last mode with which you can use Sorald, and it's Sorald in this mode is integrated into RepairNator, which is an Eclipse project. The role of RepairNator is that it can monitor commits online, monitor commits on GitHub, and then, if required, it takes some actions and then fixes, and then pushes a pull request based on those actions that it has taken. So here you see that based on this integration with Sorald, actually what happens is that RepairNator monitors commits on GitHub and then uses Sorald to fix violations, possible violations in the latest version of the program, and then pushes a pull request to fix those violations and suggest it to the developers. And overall, we created 29 pull requests using this mode of Sorald. 17 of these pull requests are accepted, 10 of them are declined or closed without being merged, and 2 of them are still pending. Actually, one of the pending ones is accepted now. This is what we had for our publication. And we also received some nice feedback from developers, from maintainers on GitHub, like the one that you see here, that is very good tool and it can help them. So we are happy about these feedbacks that we have received. Yes?
This is not photoshopped. I mean, there's a link in somewhere. You can take it from me. And the date, the user is also legitimate. Okay, so we are not the only ones in the world to focus on this problem. So the company SonarSource, they already had a static analyzer, SonarCube. Now they have also started venturing into fixing these warnings, and they have called their tool SonarLint. The URL is over here. You can have a look at it. They also deal with the same problem. They may have different techniques. So just check it out for yourself. So like any other project, there are always scope for improvement. The first one is to add more analyzers. So right now, we only use SonarCube. But there are more static analyzers, like one I mentioned, which was the Cordana by JetBrains. So like Sorald is flexible enough to have more static analyzers integrated into it, and then we can implement repairs for it. The other static analyzer is spot bugs, and the list just goes on. The second, the thing which we think is to filter out the unacceptable patches. So in one of the slides, you saw that there were actually 10 closed pull requests. So we want to investigate it further at why were they closed. So there were 2 reasons, like when we reached out to the developers. The first was that it says false positive warning. So for example, one of the warning is, you should not compare strings using double equal to, because you're actually then comparing the reference, memory reference, not the value. But what if the developer actually wants it? That's the intention. So we need maybe we could look into some way to actually figure it out. The other thing is uncertain fixes. So sometimes, like since we do static analysis, we do not have the full context. So we aren't sure that if this is actually the developer it wants. So maybe we could use some machine learning techniques. So these are our future work. And so 3 takeaways. So first, automatic repair tool. We said that we need something actionable. We did that. We have the tool called Sorald. The second thing, we use AST transformations. To our knowledge, I don't think so any other tool does that, or at least when we started developing this tool. The third, it's a part of the development process. It's very convenient to use. You can use it as a bot. So yeah, let a bot deal with your static analysis warning. These are the 3 takeaways. So thank you for listening to us. Thanks for being here. And some reference, this is the link to the GitHub repository. And if any one of you is interested in like academic publications, you can have a look at this paper. It's published in IEEE Transactions of Dependable and Secure Computing. So like I promised, there's a voting link that will be at the end. I hope you remember you had to vote for 3 ways. So you can choose any of them. And lastly, I'd like to give credit to SlidesGo, because if I don't, they might file a lawsuit against us. So yes, so thanks a lot. We are open for questions. Yeah. Yeah, yes. Yes, so yeah, like if there's a, like it mines with the handled rules parameter, so like if it can repair it, if it sees some violation which can be repaired, then it can fail the build, yes. Yes, yes, like yeah, it can fail the build, or like and like Repanator, then it can also instead if it fails, it will send you a pull request. So yeah.
Yes, actually, we didn't mention that we also have a GitHub action. It's not using I think it's not using the latest version of Sorald, but that GitHub action is Sorald build breaker. So you can add it, and it will fail your commit or pull request. And then based on that, it can generate a pull request for you to fix it. Yes.
Yes?
My question is, are you also aware of this open rewrite library, and did you do a comparison? So you mentioned this equals rule, so this is exactly one rule. I looked it up that is also supported by this open rewrite. So this is a refactoring framework that exactly does also this kind of, let's say, cleanup picture.
Okay, so I think I should repeat the question because it's being recorded. So the question is that, like, are we aware of the open rewrite framework, which also does the similar things, like it also considers repairing the comparison using double equal to? So I'm not aware. Are you?
Actually, when we say related tools and tools that are similar to ours, we are focusing on the tools that are fixing violations detected by SonarQube. I'm not sure if that one is focused on SonarQube or general, some refactoring issues. So there are many tools, actually, that do some refactoring. But the ones that are focused on SonarQube rules are the one that we have developed, and I think it's quick fixed by SonarQube itself. And there is also one more that is called SpongeBugs, I guess,
yes.
which is a research tool more similar to ours. So these are the ones that we have found. Yes.
Yes, I think. Yeah. I couldn't hear you.
Okay, I was asking if the gentleman in front raised his hand first, but gladly go. So, first of all, there is the project code checker,
Okay.
which I think would be very interesting to look at, because it does the same technique of AST manipulation, and it takes the same inputs as SonarQube. Sonar doesn't analyze things, it aggregates. It has this which aggregates like spot bugs and find bugs. I don't know. It has
And PMD, I guess.
and so this project seems to do the same thing for other languages. And I know people in it, and they're really nice, and they would most definitely love to work with you.
Okay. Yeah. Okay. So like yeah, like we should check out code checker. So yeah, we will. But yeah, like I wasn't aware of it. Thank you. Yeah. But do they do they repair it, or do they just check it, because it says code checker?
They check.
Okay.
But they do suggested bits.
Okay.
And here's my question. I'm finding that when you have a code checker or a sonar link, and it forces the developer to see what the answer is, it has two roles. First of all, it fixes the problem, but two, it educates the developer.
Okay.
With generating patches, do you have anything that you can provide to the developer to make sure that they learn at the same time also? 'Cause that's a huge value to study.
Okay. Right.
So first of all, that's actually my PhD topic, exactly explaining the patches generated by bots. And for Sorald, specifically, what we do is not that complicated. We have some templates per rule. We explain it based on the document from Sonar source itself and things like that. So when we create a pull request in the final mode, where we have the integrated version with Repainator and we automatically create pull requests, we use that template which explains what is behind the bug and how we are fixing it. But it's not based on, it's not considering the context of the issue and how it is fixed. So it can be improved, of course. Yeah.
Yes.
So maybe 2 points that Sonar itself can bring to do if you find the issue. You don't need that plugin for that. The second point, the explanation and the education for the developer is done by the Sonar plugin, which is integrated in the IDE.
Absolutely, it works for Java.
So it's for Visual Studio Code also available. Probably these other IDE also. So then there's a description, and that's the bad example, that's the good example, and why you should use that and not that, and so that's probably sample there.
I have Sonar Lint installed, I use it all the time.
Yeah.
And that's actually it. So I've seen that adding patches. I'm just hoping that it doesn't create the habit of relying too much on it.
Yeah.
Okay.
Now my question. You mentioned Sonar, and in some of the latest versions, they also introduced, at least for Eclipse, I know that, quick fixes
Yes.
for the issues. So would that be something you could consider to integrate, because that would reduce, on your side, of course, the implementation to add fixes for issues Sonar Cube itself finds and knows how to fix? Question 1. And question 2, for the analysis, you use the command line Sonar analysis. We already have a Sonar Cube analysis, which is driven by, I think, maybe Sonar, which then transports the results to the Sonar Cube server, and the issues for one branch, for instance, are there, or for one node request. Would it be possible to consume the issues to be fixed from there, so to not do again an additional analysis? And question 3, you mentioned other.
Okay. Can I answer the first 2 questions, and then so the first question is that have we considered integrating a repair bot with Sonar Lint itself? So yes, we did have a talk with Sonar Source, but it seems that like they have different ways, like they model their AST differently. So that's not, but like we have different techniques, and it's not like it's based on my perception and to our knowledge. We use AST transformations; they do something else. I am not going to. I don't think so. I'm like bold enough to say exactly what they do, but it's just my opinion. But we can talk later about that. The second question is that why do we need the mine command? Can we just consume the consume their output? So that's exactly like that's what we do. Like so, the mine actually it instantiates a Sonar Lint engine, and then it gets the warnings in a machine-readable format, which we can actually process. So yeah, that's exactly what we do. But yeah, we do not we do not need to export it to a Sonar Cube server because hey, we need it in a machine-readable format, like JSON or something. And what's your third question? Yeah. If I have answered the first 2 questions.
Maybe you could consider if you get these in the same format from the Sonar Cube server, but I don't know if that's possible. And the third point was you mentioned additional tools, that's spot bugs. As you probably know, there are additional plugins for Sonar Cube where you can add, for instance, spot bugs and probably other static analysis tools, and which also, at least on the server analysis, that background analysis, trigger additional rule violations. So server part, and of course you need a fix for the special rule of the third-party tool. It would be possible to also integrate other tools the same way.
Yes, yeah. So yeah, that is one of our future work to have more static analyzer. But it's just that it takes a lot of engineering effort. So that's why we have one. And so just for the information, like Sonar Source, like until last year it had like 576 rules. So and we just have like repairs for 30. But like according to our manual analysis, we could fix like 75 to 80% of them. But it's just that we can't write the templates. So yes.
I was about to ask in that direction. So you said that right now 30 rules are supported. How easy or hard is it to add additional rules, and would you be willing to accept contributions for that?
Yes, of course. We have a complete documentation how you can add rules, and we'll be happy to do that, to accept them. And we did actually a manual analysis with some researchers on the rules that SonarCube has. There were, I think that at the time that we did the manual analysis, there were 157 rules that it had, and we categorized them into three groups. The rules whose violations can be fixed, all of them, at least theoretically, it might be hard to do. But for example, the one that we showed, 1132, that you just have to replace the strings, it can be done automatically. Some of them are cases where for some violations, you can fix them automatically, for some of them not. And for some of the SonarCube rules, we think that they cannot be fixed at all. So our analysis shows that among, I think it was 153 rules, actually, half of them can be fixed totally, all the violations they have can be fixed. Some of them can be a bit hard. For example, if you have an unclosed resource, you have opened the file and not closed it, it's hard to fix it. But so overall, I think we have found that more than 50% of them can be fixed using our approach automatically. Yes.
Yes?
Is it possible to have rules and fixes for our own internal bug-prone framework that we have? So let's assume I have a framework and it's complicated. So developers make mistakes, but most of these mistakes are of the same chain, so we can detect those. And I know how to fix those automatically, but I don't have the framework to implement these fixes. Is it possible to have that in your tool?
So the question is, is it possible to integrate like an internal tool?
I think I can answer this one. I guess there's no problem with that. What you should do is just to have something like this. So what you do is that you should somehow have a tool, an analyzer. For us, it's SonarCube so far, that gives you a location where the problem, where the violation happens. And then you get at that location, you get an element here. At the second line, you can see we have CT invocation. So you get the element, and then using Spoon, you will do some transformations. And the pretty printing and other things is handled by Sorald framework. So what you should do is just to implement this processor for anything that you want to fix or you want to detect.
Yeah, so two things. So first, like a source, like the location, and the second thing is the processor. Yes, I saw hand somewhere here.
In your survey, you were offering three options. No, I think you should consider offering API for the tool, because there are, for example, plugins in the community for Jenkins that decorate pull requests on Bitbucket rather than GitHub. If you had API, someone might raise a pull request to those and integrate your tool in the process. For example, in a pipeline, I might not want, if possible, to do the compilation within the repair phase, because maybe I am already doing the compilation at a later stage of the pipeline, so I don't want it to do it twice.
Yes.
So it would be great if you had API besides Maven plugin and integration with GitHub.
Right.
Yeah, I think it should be possible to do that. We don't have a document that tells you how to use our library, how to integrate it, but I think that can be done, yes.
It's more like you willing to define an API, document it, and like keep it stable over releases, finding about compatibility. Because if you change everything from one release to another, then people will be crazy updating their library, their usage. No? So it's more a commitment on your
Yes.
side.
Okay.
I see.
Yes.
Thanks for the suggestion.
Any more questions? Okay, so thank you. Thanks for the questions. Thanks for the talk.